Consider the exponential equation. We got 4 of them here. Find the exact solution, okay, and an approximation to the solution rounded to 6 decimal places. So we need to isolate x, and this one 4 raised to 2x minus 1 equals 5. So 2x minus 1 is in the exponent. So we need to bring this to the ground level. And we know that when we have, let's say, a raised to something, raised to x, and if we take log with base a, then by a property of logarithm, this one jumps to the front. This exponent factors to the front, okay, times log a with base a means 1. Just that. Okay, so in this case, we can take log 4 of both sides to get 2x minus 1 to the ground. So take log base 4, okay, log 4 both sides. So that will be then log 4 of left side, 4 raised to 2x minus 1 equals log 4 of 5. Okay, we can put parentheses around. Now this one, just the exponent survives, 2x minus 1 on the top. Okay, because log 4 of 4 would be 1. That equals, now we cannot determine this using a calculator. We cannot find the value of log 4 because in our calculator we have either ln, which is natural log, or just the log log, that's the log base 10 common logarithm. So we can change this into natural log. So ln, using the change of base, this 5 goes on the top and then this one on the bottom. So the expression log 4 of 5 is same as ln 5 over ln 4. Now, our goal is to isolate x. So add 1 both sides, okay, plus 1, then divide by 2. So that gives us x equals, adding 1, so ln 5, a decimal number, ln 4, right, and then plus 1, everything divided by 2. Okay, I kind of skipped one step, but this is the exact solution. Now using calculator, we can evaluate its decimal approximation. Okay, alternatively, since we have to go for natural log anyways, we can do the following. Let's use the alternative way. Take ln both sides at the very beginning. Always take ln. When we have an exponential equation, take natural log both sides. If we do this, then we get ln of 4 raised to 2x minus 1 equals ln of 5. Okay, and from this rule, when they are not same, or let me write similar, when we have log of any base, in this case it's log with base e, of let's say x raised to b. In this case, this b jumps to the front and then left over. And this one is just a special case of this one, because this jumps to the front, this times log a of a, which is 1. So we don't write times 1. Okay, so we can always bring this to the front. It's the exponent factoring rule. Now then, in this case, this one jumps to the front. Okay, so 2x minus 1 times, what is left? ln 4, ln of 4 equals ln of 5. Our goal is to get x by itself, so times ln 4. So let's move to the other side. So 2x minus 1 equals ln 5 over ln 4. Now we are here, right? Pretty much. This negative 1 means add 1 both sides. Then 2x equals this chunk plus 1. And x is divided by 2. Okay, I'm kind of skipping one step, but this is ln 5 over ln 4. That's already there. Negative 1 means add 1 both sides, and then times 2 means divide by 2. everything over 2 I'm writing here. In each case we get the same answer, so you can always take ln. So I'm going to come back for decimal answer later. Okay, so let's do part B. So here is a 2 times e raised to 5x equals 7. There's a 2 in the front, it's a times 2. So divide by 2 both sides. Divide both sides by 2. So that is e raised to 5x equals 7 over 2. 3.5 by the way. Now this e means we need to take ln, because ln means log with base e. Take ln both sides. Okay, that implies, so take ln, you don't have to write, but I'm writing here, take ln both sides. Then we get, in the left side when we have, okay, ln of e raised to anything, this jumps to the front and leaves ln of e, which is 1. Natural log of e is 1, because natural log of e is, in fact, this is log with base e of e. When they are same, this is simply 1. So ln e of something is just that thing. So take ln and use this property. When we take ln, then this 5x, only 5x times ln e, which is 1. So we are taking ln both sides, equals ln of 3.5 or 7 halves, and now x is divided by 5. So x equals this decimal number divided by 5. Ln 7 halves divided by 5, and we can put in decimals. Okay, you can find this in decimals. So let's find the decimal approximation. In here for part A, we got ln 5 divided by ln 4 plus 1, and then all over 2. If you do this in your calculator, you're going to get 1.080482. Okay. For part B, it's ln 7 over 2, or ln of 3.5. Okay, and then everything divided by 5, you get 0.25055. Okay, so this is exact answer in natural log form, and this is approximation. That's two parts C and D. Let me erase this to make room for part C and D. In part C, we got 5 times quantity equals 11. So this is 5 times everything. So here is x in exponent, so times 5 divided by 5. So we get 1 plus 10 raised to 8x equals 11 over 5. There's a plus 1, this is 1, so subtract 1 from both sides. Okay, so 10 raised to 8x, you can write this implies this, this implies this. 10 raised to 8x equals 11 over 5 minus 1. What is that? 11 over 5 minus 1. 5 is the common denominator, because we can multiply by 5 over 5. Okay, 11 minus 5, which is 6. So 11 over 5 minus 1 means 6 over 5. Now this is 10 raised to. Okay, we got an exponential fact term here. We can take ln, but this 10 means log 10. We denote by simply log. And this is available in our calculator. So we can just take log both sides. Okay, so take log both sides. Okay, let me erase this. Then we get log 10 means that is 1, so only 8x survives, equals log 6 over 5. Then 8 times x, so x is this divided by 8. So x equals log 6 over 5 all over 8. This is an exact form solution, and we can use our calculator and find the decimal form. Okay, we'll do in a moment. Let's do part D here. Times 2, same like part C, divide by 2. So 6 plus 8 raised to x plus 1 equals 100 divided by 2. It's 50. Then there is a 6 is a plus, so subtract 6 from both sides. So 8 raised to x plus 1 equals 50 minus 6, 44. Now this is 8. We can take log 8, but log 8 of 8 something is just that something, right? It jumps to the front. But then we have to take log 8 on the right side as well. Well, our calculator does not have log 8. So we can take log 10 or ln both sides. So take ln, I mean, that will work. Take ln. Like I showed earlier for an alternative way for part A. Take ln both sides. In part C we have 10. So 10 is, log 10 is available in our calculator. Okay. Take ln, and then that would be, you can write ln, and that makes x plus 1 to the front ln of 8 equals ln of 44. Now it's a times, so divide by ln 8. So x plus 1, we don't have to write parentheses anymore because there is nothing to multiply, ln 44 over ln 8. Okay, do not cancel 44 and 8, okay, just leave that. Now is a plus 1, subtract 1 from both sides and done. So x is this junk minus 1. Okay, this is exact form of solution, and we can use our calculator and find an approximation. So after for part C we had this exact solution, and once this in your calculator, log, okay, like this, as log in our calculator, we get this. And for part D, when we do ln 44 over ln 8 minus 1, we get this. And we need to round to 6 decimal places. Okay, final.